Hello and welcome back to my channel Code with Ease by Varsha. We are doing a series on coding patterns. In the previous videos, we have discussed about the introduction and overview of coding patterns, what they are, why they are being used, what problems they are trying to solve, how they are being used. So I would highly recommend to check that out. I'm going to link it up in the description below. If you're someone who's learning DSA for the first time or is a working professional who wants to revisit the basics, I think coding patterns comes to the rescue because it gives a holistic 360-degree picture of what you are learning. So it just helps to plan the learning better. And as part of this series, we are going to cover in depth about each and every pattern, what they are, the pattern is, why the pattern is being used, how can we identify such patterns in the questions, look for clues in the questions, what is the underlying technique behind every pattern, and all of that we are going to cover. So I'm hoping this would help many of you guys. So stay tuned, and if you wish to get further updates on this coding pattern series, please don't forget to subscribe to the channel and press the bell icon, of course. So without further ado, let's jump right in. Pattern that we are going to talk of today is called the fast and the slow pointers. Extension or a different flavor of the two pointers algorithm. If you guys are not aware of what two pointers algorithm are, we have already covered that in one of the earlier videos of the coding pattern series. I would highly recommend to check it out. So check out in the description the playlist for the coding pattern series. Two pointers algorithm forms the base, and once you guys understand what two pointers technique is, it's easier to understand what other different flavors are of. Just to recap on this, nothing but these two pointers are the names of two different variables which will point at two different indexes of the underlying data structure, like it can be an array or whatever. And then the pointers, the variables, or we can say the whatever that variables are pointing to that index, it is going to move in different direction. It can move in same direction and then manipulate it accordingly. The biggest reason why this two pointer technique is very useful and it comes in handy when we have to reduce the time complexity from order of n square to order of n. Anywhere where you are seeing a nested for loops being used, increasing the time complexity, using the two pointers technique helps us to optimize the performance of the algorithm. And that is why we use this. Simple reason is it can be solved in a single scan of this entire data structure because the two pointers are pointing to two different indexes. So instead of us doing one scan of the array and then again waiting and doing another scan of the array, we can do it in one scan only by making it point to two different index positions. Okay, so that is the biggest advantage of two pointers, and that is also going to get carry forward in all the different flavors of two pointers technique. So fast and slow pointers is also nothing but the names of the two different variables. Okay, and this is depicted the it is depicted by the pace at which these two variables are moving. That is why the name is also there, fast and slow. It is also known as hare and tortoise. It's a famous childhood story that we all have studied. The hare is moving at the faster pace and the tortoise is moving at a slower pace. So names of two variables determined by the pace at which, the speed at which they're moving. So now the next question arises as to why do we need this pattern? So this pattern is useful to determine the behavior of the underlying array. It can be a linked list, it can be a graph. Now, when I say behavior, I specifically mean the behavior of cyclicity. So, what does cyclicity means? Like something, a data structure which is cyclic in nature, something which has a loop in within. So, let's consider an example. Let's say we have a linked list, and how does it look like? There's a head node, and all the nodes are chained together. So, one node points to the memory address of the other node, and so on. So, all the nodes are chained together, and the last node of the singly linked list points to null, and the last node is called tail. So if this is the pattern, so in this case, is there any loop? No, there is no loop. What causes a loop in a linked list? If one of the nodes is pointing to an existing node, okay, let's say this node points to this. So in that case, what will happen? Where if I'm starting from here, I'll go to this node, then I'll go to this node, then this node, and then I'll come back to this, and again this node is pointing to the next. So it's like an infinite loop kind of a thing. There is like the nodes are not pointing to the null. There is no tail node pointing to null. So it's like a loop within loop. So this kind of a nature, if it exists in any data structure, that can be helpful That can be found out if we use this fast and slow pointers. Okay. So how it helps, so how it works, we'll see how the pointers are going to move, how it helps to understand whether there is a loop in our linked list or not. So that is what the gist of this technique is. So let's just do a dry run of how this fast and slow pointers work in action. So same thing, let's say I have this linked list. So how this works is there is a fast pointer and there's a slow pointer, like we said. So this fast pointer moves 2 steps ahead, like we initially talked of. The only difference between these pointers is the pace at which they are going to move. And the slow pointer is going to move only 1 step at a time. So when I say that, let's say fast and slow pointer starts from this head node over here. Now the fast pointer is going to move 2 steps ahead, means from here it is going to jump to this and then it is going to jump to this. So fast comes over here. Slow pointer, however, will only move 1 node at a time. Again, fast pointer will jump from to this node and then it will come to this node. So fast comes over here. However, slow only moves 1 node at a time. Again, fast will jump 2 nodes ahead. So it is over here. It will jump to this and this. So fast comes over here. And slow goes 1 node ahead. So slow comes over here. So eventually, slow and fast are meeting at a node. Okay. So the theory, this technique, what it talks of is, if 2 pointers are moving at 2 different pace, one pointer is moving 2 steps ahead, another pointer is moving 1 step ahead at any given point in time, both the pointers are supposed to catch each other, means fast and slow will meet. Like initially they were at the same position, at some point they have to meet. If they meet, if this is true, then there is a loop which exists. Okay, so what it means is, if there is a circular track like this, there is a runner who is a bit slow, like there's a hare and there is a tortoise. So if the hare is moving fast enough and the tortoise is moving slowly, at some point in time the hare will be able to catch the tortoise because it is a circular track. So no matter how slow the tortoise is running and no matter how fast the hare is running, at some point they're again going to meet each other. And this is the crux of this pattern. And because we detect a loop in a linked list. So what are the popular applications of this kind of a pattern? First is, like we told, to detect if there is a loop in a given linked list or not. Another application is if you have to find a middle point in a linked list. In that also, this is helpful. Okay. How can we identify if this pattern needs to be used? First and foremost, the very simple thing is the term loop, the term cycle. These kind of terms can give a hint that this technique can be used. Another hint which we can use of is wherever, now this again boils down to the 2 pointer technique again. So wherever there is a requirement that you have to traverse the data structure twice, traverse twice means something like, okay, I have to determine what is the length of the linked list, and then after determining the length I have to do certain things. So in that kind of a scenario also, it is useful to try to see if we can use these fast and slow pointers to somehow to prevent from traversing twice. So no need of traversing twice if I can do it in one traversal only, if that is also a requirement. So single traversal, single scan. Okay, so these are the few things in which fast and the slow pointer technique can come into play. So with that, it's a wrap on today's session. Don't forget to like and share the video so that it can reach out to others. And also please don't forget to subscribe to this channel, press the notification bell so that you can get further updates whenever we publish a new video on this channel. Thank you so much for watching.